I'm going to go through the review packet, the first midterm review packet. So this is midterm review number 1. And I'll break it up in a couple of videos. I'm not sure how many. Alright, so first one, Venn diagram for the following statement. If a quadrilateral is a square, then it is a rectangle. So what is this saying? It's saying that anything that's in the square category is also in the rectangle category. So we'll just look through that. The whole quadrilateral part is kind of a red herring. It doesn't really matter to the problem. So what we're looking for is the one that shows me that anything that falls in the square category falls in the rectangle category. So here you can see that there are things, because the circles are just overlapping, there's just, I could have a square here, I could have something in this category that's not in the rectangle category, so it's not that. Going around here, there's no overlap, so nothing in the square category is also in the rectangle category. So that can't be it. We want the one that has all the square things in the rectangle category. Now here you've got the rectangles. All the rectangles are in the square category. That's not really what we want. It's like we could have squares out here, right? Just do this, just draw one. Okay, so if it's in the square category, but it's not in the rectangle category. So this would be saying that there are some things that are squares that are not rectangles. Finally, this one, everything that's in the squares, no matter where I put, anything I put in here, in this circle, the square category, is also going to be in the rectangle category. So that's the one that I want, since all squares are rectangles. All right, ratio. Which ratio represents the slope of the line parallel to line F? Well, parallel means same slope. We can do this any number of ways. We could do rise over run. We know slope. Let's write that over here. Equals rise over run. We also can do slope equals y2 minus y1, x2 minus x1. We've got our 2 points here. I think when you have a graph, it's easiest to just do rise over run. To go from this point to this point, I go down 3, so that's negative 3, and then over 1, 2, 3, 4, 5, 6, 7, 8, 9, positive 9. So my slope would be negative 3 over 9, which simplifies to negative 1 third. If I did it the y2, y1, x2, x1, I would do, so I can just call this x1, y1, x2, y2. Doesn't matter which one's the 2, which one's the 1. I would get 4 minus 7 over 5 minus negative 4. Alright, 4 minus 7, negative 3 over 5 plus 4, positive 9. Again, that's the same as negative 1/3. Obviously, you get the same answer either way, negative 1/3. And so, notice that none of the answer choices are negative 3 over 9, so you're going to have to simplify that. Alright, let's go on the next page. Okay, so number 3. Alright, P is Jane does her homework. Q is Jane gets an F. Symbolically represent the following argument. If Jane does her homework, then she will not get an F. So, Jane does her homework. What is that? Well, that is P. That is exactly what P says. She will not get an F. What is that? Well, Q is she does get an F. So, she will not get an F would be not Q. Remember, our symbol for not is the little squiggly line. Okay, and we have an if, then. Remember, if, then, if, then is our little arrow. Something here, something here. If P, then Q. So we have if P, then, and we have a then here, and then we have not Q. Jane will get an F. What's that? Jane will get an F. That's our Q. The things with, she, or Jane, that's the same, but over here we had she. Just those things don't make any difference to which proposition we're dealing with, P or Q. Also, it says gets an F. Here it says will get an F. Those kinds of things, tense, they don't make any difference to what we're talking about. So we got Q. Now, final thing, Jane does not do her homework. Well, P is the one that's about Jane and her homework, but it's Here it is not do her homework. Here it is does her homework. So that's going to be not P. And that's all there is to it. Question 4. Based on the information given, which diagram could be used to prove that J is parallel to K? Okay, well, if we look at this diagram, we've got our big angles, both 130. So we've got two congruent big angles. That tells me that J is parallel to K. But I don't have anything about M and N here. I don't have anything about N at all, so it can't be this one. Right? I want to prove that J is parallel to K and N is parallel to N. All right, if I look at this one, I've got my small angle 50 and my big angle 130, and they add up to 180, so they're supplementary. So that's good. That tells me that M and N are parallel. So I got M parallel to N. But I don't have anything about K, right? So it can't be this one. So I can't tell that J is parallel to K. Keep going. C. I've got 130 here, and I've got 50 here. And then I've got another 130 here, so I've got two bigs, small. But I don't have anything on the same transversal. So, like, I don't have anything tying J to K by way of this transversal M. And I also don't have anything tying J to K using this transversal N. So it can't be this one. I have to have that one transversal that tells me information about both of the lines that I want to show are parallel. If I go to D, that leaves D, so we should just check to make sure it works. Okay, we've got 130 here, big angle, 130 here, on the same transversal. So they're both part of the same transversal. So that gives me J and K parallel. So I get J parallel to K. If I go down here, I've got 130 here, big angle, and I've got small angle 50. So those two are supplementary. That's good. It's big and small, supplementary. And it's on the same transversal K. So that's enough to tell me that M is parallel to N. So that's my answer, D. All right, I'll stop here and do another video.